Swayam Prabha. Digital India. Educated India.
Discussing the module 8 of organic chemical technology, and already we have discussed about the polymer and the elastomers. Today we will be discussing one of the very important sector of chemical industry, which is playing very important role in meeting the one of the major demand of the mankind, that is the clothing. So today we will start with the nylon 6 and nylon 7, which is the one of the very important synthetic fiber. So the coverage of the lecture, that will be on the introduction, capacity and the production of nylon 6 in India, because we are not making nylon 66, mostly it is in nylon 6 that is available. What consumption of non-woven man-made fibers, and what is the percentage of the nylon 6 and nylons in the, because we are having the different type of the nylon 6, nylon 66, nylon 12, nylon 13, like that. So global caprolactam production and the demand scenario, feedstock for nylon 66 and cyclohexane, because cyclohexane, that is the starting material which is coming from the benzene, and so they will be detailing the process flow diagram for the cyclohexane manufacturing various routes of the caprolactam, because a number of the routes are available for the making of the caprolactam, but the cyclohexane remains the one of the important feedstock. Other routes are from the toluene to benzoic acid and other routes, but the major route is from the cyclohexane, and through the same final Beckmann arrangement of the reaction. That is then we will be discussing about the caprolactam, what are the processes for the caprolactam, and in detail about the one of the process which are using in India, and nylon 6, the manufacture of the nylon 6, because they after making the caprolactam, that will go for the polymerization, and then the feedstock will be again will be discussing about the nylon 66, introduction of the nylon 66 and feedstock for the nylon 66, which is adipic acid and hexamethylene diamine, and then the process of the manufacture of the nylon 66. This is the importance of the caprolactam, and you can see the large application, and that was the first Paul Seclac, that was the who was the first polymerization nylon 66, nylon 6 from the caprolactam. He was the man who was about the invention of the nylon 6, and so these are the various application of the nylon 66, and now it is not only in the synthetic fiber, means the woven industry, a huge amount of the nylon 6 that is going to the non-woven industry, even the electrical appliances also we are using nylon 66, nylon 6, and these are the some of the threads, parachute and the other application of the nylon 6, and especially as I told you, the electrical application means the switches, MCB, and there we are using the now the nylon 6, which was earlier the backlight switches that we are using, but now we are using the nylon 6 or the polycarbonate there. Let us go to the history of the nylon 66. Although history of the textile market using natural fiber is from the ancient time, however, 18th and 19th century witnessed an era of the industrial revolution, resulting in the tremendous upsurge in the fiber production. Real driving force for the development of synthetic fiber industry has been due to the availability of feedstock from the petroleum and petrochemical. But during the 1910, 19 and up to 30, and the other routes were also available for making of these synthetic fiber, whether it is in your nylon 6 or the polyester or the acrylonitrile alternative routes was there, but it was the real breakthrough or the main driving force has been for the development of the synthetic fiber industry is the availability of the feedstock from the petrochemical. Among them, because nylon 6, nylon 66 is coming in the category of nylon polymides. Polymides were first discovered and evaluated in 1929. Nylon 6 and nylon 66 are the two major polyamides and comprise about 85 to 90% of the total nylon produced, which find wide application in synthetic fiber, nylon tire yarn and other application. Because of the high melting point, although the nylon 66, because it is having higher melting point than the nylon 6, and so the but still the nylon 6, because of its feedstock from the benzene we are making, so it is more preferred, or because the availability of the nylon 6 is more than nylon 66. Resins are the important market for the nylon, whether nylon 6 or nylon 66. Some of the other nylons which were developed are nylon 46, nylon 69, nylon 612 and nylon 11, nylon 12, nylon 1212, like that. A number of the variation in the nylon is there, but nylon and nylon 66 are the important polyamides. Nylon 6 and nylon 66 are two important polymers, two important nylon 6 and nylon 66 are the two important polymers and find application in oven and non-oven, because you see we are having the application of the synthetic fiber both in the oven and non-oven industry, means the tire cord and other applications are also there in the switch. As I told, the electrical appliances we are using the nylon 6. So, the oven and non-oven both are the major consumer of the nylon. Caprolactam is the monomer for nylon 66, nylon 6, while monomer for nylon 66 is the nylon salt, which is made from the adipic acid and hexamethylenediamine. These are the two raw material for the nylon 66, which is reacted, and then we are getting nylon sheet and nylon salt that is polymerized to nylon 66. Nylons are exception, all strong, elastic, abrasion resistance, lustrous, easy to wash, resistance to damage from oil and many chemicals, low in moisture. This is one problem in case of the, because during the early stage when the nylon came into the market, so nylon that was used in the textile also, but as the nylon low moisture absorbency, it was not very comfortable in case of the for the textile purposes, and so its application of the nylon 6 was limited to the hosiery and non-woven industry. So, nylon fiber find application in apparel, home furnishing, tire cord, hose conveyor and seat belts, parachutes, racket strings, ropes, tents, thread, monofilament fishing line, then the dental floss. So, these are the some nylon 66 is preferred for tire cord because of the high melting point. Here slightly difference in the about 10 degree centigrade difference is there in the melting point of the nylon 6, it is higher than the nylon 6. That is why the nylon 66 is preferred, although it is preferred, but availability is a major issue in case of the nylon 66. Nylon 6 is the first synthetic fiber introduced in India, and I remember during the 1960 it was the nylon 6 came to the market. Installed capacity in production of the nylon filament yarn and nylon industrial yarn is 3,60,000 and these semi lakhs tons 36,000 70,000 tons and 33,000 and the 86,000 tons in 2010, 11 respectively India. This was the figure of the production, that was the 36, that was the idea. But so far the nylons caprolactam is concerned, this is the capacity and production of the nylon 6, nylon filament yarn, nylon industrial yarn. So, this is the 36,000, 33,000, 77,000 and 86,000. This is the status of the world consumption of the non-woven man-made fiber, which we discussed while discussing the polymer, elastomer and synthetic fiber. Here you see although the polyamides are a small portion of the total man-made fiber, because the major is your this polyester, but the viscose yarn is also the and that is playing important role in the synthetic fiber industry. Let us discuss about the feedstock for nylon 6. As I told you, the major raw material for the or the monomer for the nylon 6 is the caprolactam. And caprolactam, there are various routes for getting the caprolactam. One is the cyclohexane, which we are getting from benzene, benzoic acid, from toluene, that may be another route, ammonia and sulfuric acid that we need here. One of the drawback of the earlier caprolactam technology were that the production of the ammonium sulfate, it is around 3 times the amount of the caprolactam that we are producing in the form of the ammonium sulfate. That was the and that led to the development of the some of the greener technology in the manufacture of the caprolactam, where no ammonium sulfate is produced. So, this was the this is the one of the development that has taken place in the caprolactam technology, because we need the ammonia and sulfuric acid. The production of the caprolactam, that is confined to fertilizer complexes where they are making both ammonia and the sulfuric acid. This is the status of the caprolactam manufacturing in India, and we are having the two major units which are so one is the Gujarat State Fertilizer and the at Vadodara, a large integrated complex, and second is the fertilizer and chemical 7 core. So, these are the two units which are producing caprolactam. Another unit was to come in Paradip by Modi's, but that was due to some or other reason that project did not come. Another actually for nylon 66, as I told you, the nylon 66 we need the two raw material, major raw material, that is the adipic acid, hexamethyldiamine. So, for the adipic acid also the various routes are there which we can get the adipic acid, but cyclohexane, which is from benzene, that is one of the major route. Another route is the phenol, butadiene, adiponitrile. From the adiponitrile the butadiene, from the butadiene we are getting adiponitrile, which is used for the adipic acid. Propylene, that is another route for making of the, because that is being used for the in the manufacture of the other intermediates, which is finally converted to the adipic acid. Another important, that is the hexamethyldiamine, that is the adiponitrile, from the acrylonitrile where we need the propylene, butadiene or the adipic acid. These are the some of the other routes for the making of the hexamethyldiamine. Let us now discuss the cyclohexane, which is the major feedstock for the and the most of the process they are using the cyclohexane for manufacture of the caprolactam. Cyclohexane is an important chemical intermediate derived from benzene. It is used for the manufacture of adipic acid and hexamethyldiamine also, and which is used for the manufacture of nylon 66, and caprolactam used for the manufacture of nylon 6. Major portion, about 90% of the cyclohexane is used in the manufacture of nylon fiber and nylon molding resin, and remaining 10% of the cyclohexane ends up as solvent in plasticizer. This is the process how we are making the cyclohexane. Cyclohexane is made by catalytic hydrogenation of benzene in liquid phase or the vapor phase. UOP hydrogenation process uses liquid phase hydrogenation of benzene at 200 to 300 degrees centigrade in presence of platinum based catalyst promoted by lithium salt at 3 megapascal. This is the reaction that is taking place after the hydrogenation of benzene. We are getting the cyclohexane. In the IFB process, again the cyclohexane is produced by liquid phase hydrogenation. Only the difference is in the catalyst and the temperatures, lower temperature required, and this is the reaction that is taking place. This is the process flow diagram for the manufacture of cyclohexane by the benzene that is going to the hydrogenation tower, and from the hydrogenation tower the product that is going to the high place, and from the high place the hydrogen that is it is recycled to the system and make up hydrogen that is added there, and so the offset at the separation it is going to the flash low pressure, and from the low pressure again the light products that we are getting, and then this finally we are getting the cyclohexane from the bottom of this flash low. Now let us come to the caprolactam. Caprolactam is the principal raw material for nylon 6, which I told you a versatile material used as fiber, industrial yarns and flooring, covering, as for engineering plastic, because the vinyl flooring that the flooring that also we are using this nylon. Nylon 6 was first made in 1899 by heating 6 amino hexanoic acid, but commercially feasible synthesis for caprolactam was first discovered in 1935 by Paul Saleh. There are various routes for manufacture of caprolactam. However, 90% of the world's caprolactam is produced from cyclohexane oxime via Beckmann rearrangement. This is the major reaction that is taking place. Most of the process through hydroxylamine sulfate route. Ammonium sulfate is byproduct, as I told you, about 3 times at the various stages the ammonium sulfate we are getting in the process, and so it is almost 3 times of the amount of the caprolactam which we are producing. So, hydroxyl amine phosphate oxime process, ammonium bisulfate is obtained, which is evaporated and finally incinerated to give SO2, which is further converted to SO3 in presence of the vanadium pentoxide and used in the oleum production which is used. So, this is the in the process that we are using the sulfuric acid also. So, the global caprolactam production and demand scenario, this is about the caprolactam, and so for this is the global, but in case of the India there has been not much increase in the production of the caprolactam, because these are the only 2 units which I told you, Gujarat State Fertilizer Complex GCFC at Vadodara, and the fact they are the 2 major producer, and some of the units they are importing their caprolactam, because DSM, this is also one of the company which is multinational company which is making the nylon 6. So, as I told you, there are various routes, that is from where we are getting the, but finally the caprolactam in most this is the Beckmann rearrangement, and that may be from the benzene to phenol, or the benzene to cyclohexane, or benzene to nitrocyclohexane, or this may be benzene to cyclohexane, then the toluene to benzoic acid. So, these are the some of the routes, and similarly in case of the union carbide, again the cyclohexane, because during the process cyclohexane is converted to cyclohexanone, which is actually going for the further reaction, and cyclohexanol is also produced, which is recycled in the system. This is the cyclohexane process where we are getting the cyclohexanol is converted to cyclohexanone, and then the Technichem process, that is the again the cyclohexane process that we are using, and finally the during the oxime cyclohexane Beckmann rearrangement we are getting the your caprolactam, and during the process we are generating also, as I told you, the ammonium sulfate. So, these are the two major producer of the caprolactam, which I told you, Gujarat Chemicals and Fertilizer at Vadodara, and this was started. This is the one of the largest integrated fertilizer complex, which is not making only fertilizer but also some of the important, like it is not only caprolactam, they are making the nylon, they are making the that melamine also, which is produced from the urea, fertilizer and chemicals, 7 core, and that is also another unit which is making the caprolactam. So, the process step for manufacture of caprolactam from cyclohexane, 3 steps are there. One is the manufacture of cyclohexanone, the manufacture of hydroxylamine sulfate, and manufacture of the final caprolactam. So, these are the 3 major section in case of the production of the caprolactam from the cyclohexane. So, first step, that the manufacture of the hydroxylamine sulfate, production of the ammonium carbonate. So, first step is the production of the ammonium carbonate by absorption of CO2 in 24% of the ammonium solution. Production of the nitrous oxide from mixture of NO and NO2, which is produced by combustion of ammonia in presence of the platinum catalyst at 85 degree centigrade. So, this is the process from where we are getting these two nitrous oxide mixture which is used in the process. Then the absorption of the nitrous gases from the ammonia combustion in ammonium carbonate to yield ammonium nitrate. Reacting SO2 with the ammonium nitrate, ammonium carbonate, which result in the production of hydroxylamine sulfate. Finally, hydrolysis of hydroxylamine disulfonate, that was the production of hydroxylamine disulfonate, and after the hydrolysis of this hydroxylamine disulfonate, we are getting finally the hydroxylamine sulfate and ammonium sulfate as a byproduct. In subsequent stages, the cyclohexane is oxidized in multi-compartment reactor at a temperature of around 160 degrees centigrade and 10 atmosphere pressure, where the liquid flows in series from one chamber to another using cobalt salt as catalyst. The product steam is treated with the sodium hydroxide to neutralize the acids, sapronify esters, and to decompose the peroxide. Sodium salts, which are immiscible with the main product steam, are separated in a gravity settler. Organic phase containing cyclohexene, cyclohexanol and because we are getting the mixture of the cyclohexanol and the cyclohexanol and the plus some unreacted cyclohexane. So, the cyclohexane is cyclohexanol that is recycle, and cyclohexanol are fed to a series of 3 distillation column for the separation, and though finally we are getting the cyclohexane, which is the again recycle, and the product is the cyclohexane finally, which is needed in the process. Cyclohexanol separated in the last column as bottom product is dehydrogenated to cyclohexanone, because the cyclohexanol is in the process we are getting. So, the cyclohexanone in the presence of zinc carbonate and calcium carbonate catalyst at 400 degrees centigrade. The unconverted cyclohexanol and cyclohexanone after removal of lights recycled to the third distillation column for recovery of the cyclohexanol. Then the manufacture of the caprolactam. The manufacture of the caprolactam is the production of cyclohexanone oxime by reacting cyclohexanone and hydroxylamine sulfate, because one unit is the production of cyclohexanone and another is the hydroxylamine sulfate, that is the reacted in a multi-compartment reactor, these two, and then during this process ammonium sulfate again it is formed as a byproduct. Caprolactam and the aqueous ammonium sulfate are sent to a series of extractors where toluene is used as a solvent. Ammonium sulfate collected from the extractor bottom is purified, crystallized, centrifuged and dried. caprolactam solution is concentrated in multiple evaporators and finally purified. This is the manufacture of the caprolactam, three major units which I told you. One is the production of the cyclohexanone, where after the oxidation we are getting the cyclohexanol, which is recycled here, and then the cyclohexane finally it is going here in the reactor, where it is reacted with the hydroxylamine sulfate. This is the production of the hydroxylamine sulfate, where the ammonia oxidation it is going to reactor, where ammonium carbonate that is fed to this reactor, and in here from the nitrous oxide that is going to reactor, and the SO2, and then the hydrolysis, and finally the hydroxylamine sulfate which are getting. But again here also you see this at this stage also we are getting the ammonium sulfate, and this is the finally what is happening here, the cyclohexanone and the hydroxylamine sulfate that is reacted here, and then after the Bachmann rearrangement that we are getting this is the Bachmann rearrangement reactor, where we are getting the caprolactam, and then finally the caprolactam is separated. This is the reaction that is taking place in the hydroxylamine sulfate, where the NH3, the mixture of this NO2 we are getting, and then again this is reacted with the ammonium carbonate and this ammonium nitrate that we are getting NH4, NO2, and this NH4 and 2 again with the SO2 that is going to the hydroxylamine disulfonate which I told you, and this amine disulfonate again after hydrolysis that gave your hydroxylamine sulfate and the byproduct ammonium sulfate that we are getting. Now after getting the caprolactam, the next section in case of the nylon 6 preparation is the nylons polymerization of the caprolactam. So nylon 6 is produced from polymerization of the caprolactam. So the process consists of the caprolactam melting and addition of additives, polymerization, batch or continuous, and fine chips production, because after the polymerization we are getting the nylon chips, and that chips again depending upon that can be used for the spinning, weaving. In case of the nylon 6 we are using the melt spinning. So chips washing and drying, spinning of the nylon, and the recovery section. These are the various units are there in case of the nylon 6 manufacture. So this is actually the caprolactam is polymerized to nylon 6 polymer by ring opening polymerization at 240 to 270 degrees centigrade in presence of water, which opens the ring structure of the caprolactam to give the amino caproic acid. This is the manufacture of the nylon 6, that is the caprolactam, additives, filtered, and then the polymerization reactor, and after the polymerization reactor we are getting the nylon chips, either it may be in the form of the nylon chips or the nylon chips that may go to the spinning section where the melt spinning process. And in case of the melt spinning, what we are doing, we are having the number of spin rate through which the melted nylon 6 that will be passed, and while coming from that will be dry up, and then we will be getting, and then it will be the various stages are involved, twisting of the yarn which you are getting, or if you want to make this staple, then you will have to cut it the staple, or it may be in the form of the yarn. So this may be nylon 6 yarn or the staple, and these are the reaction that is taking place, which I told you, the ring opening, and then the polycondensation reaction that is taking place in the making of the nylon 6. This is the caprolactam plant of the Gujarat State Fertilizer and Chemicals Complex at Vadodara unit, and this is the nylon fiber unit of the your Gujarat State. And these are some of the actually the product and nylon 6 filament yarn and the application and of the nylon 6, and that is there, and this is the actually the required denier that I discussed while discussing the introduction of the polymer elastomers, that this is the one of the very important denier tenacity. These are the important measurement of the your this yarn. These are the another actually application, because one of the major user is the tire car industry, and these are the other products that you are getting. Now let us discuss the nylon 66. Already I have told you the why we are going for, why we are interested in nylon 66, because nylon 66 is having the higher melting point than nylon 6. But here we need the two important feedstock, that is the adipic acid and hexamethyldiamine, and one of the technology for the adipic acid that has been developed by the IIT Dehradun in India, and that has been commercialized also. So the adipic acid, what we need the cyclohexane from benzene, or the phenol, butadiene, propylene, and hexamethyldiamine adiponitrile that we need from the, which may come from the acrylonitrile, butadiene, or the adipic acid. Let us now discuss the adipic acid. Adipic acid is the basic raw material for the manufacture of the nylon 66. World over demand for the adipic acid is growing by 3.6% during 2000 to 2010. Adipic acid is manufactured from number of starting raw materials like phenol, cyclohexane, tetrahydrofuran, etc. Various routes for the adipic acid are, these are the, as I told you, the large number of the raw material that we are using here. It may be the phenol, it may be the benzene or butadiene or the propylene route, but the major production of the your adipic acid is the through the cyclohexane route, and there cyclohexanol and cyclohexanone that we are getting, and then phenol also cyclohexanol. Here is the dichlorobutene, and then the adiponitrile and adiponitrile route, which I told you. So these are the some of the routes that we are getting. So in the process, cyclohexane is oxidized by air to form when the cyclohexane is the raw material. Then the cyclohexane is oxidized by air to form cyclohexanol and cyclohexanone in presence of the cobalt naphthalene catalyst at temperature of 145 to 150 degrees centigrade. The cyclohexanol and cyclohexane mixture is oxidized to adipic acid in presence of nitric acid using ammonium metavanadate and the copper scrap at 60 to 80 degrees centigrade. Adipic acid form is crystallized, centrifuged, and finally dried with air. So this is the method for making of the, and various routes already I discussed we are having, but phenol route or the butadiene route or the propylene route, but benzene route is the more preferred, because the benzene that is available from the aromatic plant or the catalytic reforming plant, and so that benzene, and this is the reason why even for the making of the caprolactam we are using the benzene route now. The next product, the feedstock which we need for the nylon 66 is the hexamethyldiamine. Hexamethyldiamine is the intermediate for the manufacture of nylon 66 and manufactured by the catalytic hydrogenation of adiponitrile. These are the processes that we are using, high pressure technology or the low pressure technology, where the catalytic hydrogenation by adiponitrile in presence of catalyst is taking place. This is the catalyst in low pressure is nickel, whereas in case of the high pressure it is cobalt and copper. So this is the reaction that is taking place in case of the hexamethyldiamine. This is the process that we are using in making of the hexamethyldiamine, adiponitrile and air that is going to the hydrogenation, then it is going to the your finally we are getting here in the process filtration and washing, then it is going to azeotropic distillation, and the crude hexamethylene diamine here we are getting, that is going to diaminocyclohexane recovery, and finally the separation where the heavy ends we are separating and hexamethylene diamine, that you are getting the final product which is going for the manufacture of the adipic acid for the nylon 66. And so the two major raw material which is required for the nylon 66 is the adipic acid and hexamethylene diamine. So nylon 66 is produced by polymerization of adipic acid and hexamethylene diamine. What is happening during the reaction, the nylon salt is made by the reaction of the adipic acid and hexamethylene diamine, and the which is further polymerized. Polymerization of the nylon salt into a jacketed vessel equipped with internal coils and heated by diatherm, cooling and chips production. Spinning of the nylon 66, here also we are having the melt spinning and the recovery section. This is the reaction that is taking place when we are having the adipic acid and hexamethylene diamine, and by the reaction we are getting the nylon salt, and this nylon salt after the polymerization we are getting the nylon 66. So, this is the reaction that is taking place in production of nylon 6 from hexamethylene diamine and the adipic acid. This is the process that we are using. Again here also the nylon salt and then the nylon salt autoclave where the polymerization is taking place. Then the final here also the same way as in case of the nylon 6, either you can have the chip form, and then the chip can be used for the because the downstream processing of the nylon 6 or nylon 66 units are there, directly they are taking the nylon 6 or nylon 66 chips, which is further process means the spinning is done, and so the spinning part, that is the, as I told you, is the melt spinning both in case of the nylon 6 and nylon 66. So, the again here in the spinning process melted nylon 6 is passed through the spinnerate, a large number of the spinnerates are there, and that through the spinnerate that is passed and the continuous thread is coming, and then we are getting the nylon yarn which may be also cut to the staple form. So, the continuous spinning, then the twisting, then the toe of the your nylon 66 that we are getting. So, this is the in brief about the nylon 66 process that we are using. So, this was about the two major product nylon 6 and nylon 66, but as I told you the only nylon 6 we are making in India, and two major is nylon manufacturing the caprolactam for the nylon 6, that is your GCFC and the fact, and the raw material and whatever the development that you are seeing in case of the caprolactam technology, that is the people are now going for more and more greener technology, because that is one of the major problem, that is 3 to 4 times of the your caprolactam is the ammonium sulphate, and huge amount of the ammonia that is required. So, but at the same time you see the nylon 6 or the nylon 66, they are playing very important role in meeting some of the demands of the synthetic fiber industry. In the next lecture we will be discussing about the another important sector of the synthetic fiber industry, that is the polyester, and the polyester again, and there has been continuous development in the technology in the raw material shifting from the DMT to terephthalic acid and or the purified terephthalic acid. This was the major changeover in the process technology of the polyester, and polyester, that is one of the major synthetic fiber which we are using both in the oven and non-oven industry, major application in the non-oven. And again the real breakthrough in all the case of the synthetic fiber, that has been because of the coming of the petrochemical complexes and the aromatic production.